Hello everyone, I am Daniel NSC and today I'll be talking about centripetal and centrifugal force. Um, First of all, centripetal force is the force that keeps an object rotating in circular motion. Circular motion. It is always directed towards the center of the circle. So let's take for example a string connected to a stone and the person pulling this string. So as long as the person keeps pulling this string and turning it, it's going to keep rotating in circular motion. And so the force that is directed towards the center of the circle, that's the person's hand, is the centripetal force. We can call that FC. FC, the centripetal force. The acceleration at which the stone moves, um, at which the stone actually changes its angle, it's called the centripetal acceleration. In uniform circular motion, the stone does not increase in speed, so it only experiences increase in its angle, which is its direction. Yeah, so for the centrifugal force is the force felt by the object, which makes it um, which makes it feel like it's going outside of the circle. Let's take example this Ferris wheel. In case you didn't notice, this is a Ferris wheel. If there's a person here, while the Ferris wheel is rotating, the person will feel like they are flying out of the Ferris wheel. So the force that makes you feel like that is called centrifugal force. So just to recap, centripetal force directed towards the center of the circle, centrifugal force makes you feel like you are flying out of the circle. Okay, so I'm going to be using example of a Ferris wheel to see how the centripetal force acts on an object. At the top of the Ferris wheel, the centripetal force is directed downwards because it's always directed towards the center of the circle. And let's say there's a person here. This person has a weight, and that weight is mass times acceleration due to gravity, and also there's a normal force that's preventing the person from falling through their chair, and that's N. Here, the normal force is always acting upwards. The weight due to gravity is always acting downwards. So I'll say mg, and the normal force is pointed upwards. So this should be my positive y-axis and my negative y-axis. So when the object is at the top, the normal force is acting upwards, the weight is acting downwards. So that's why I set my axis plus y and minus y here. Um, so we are going to see force acting on the system. I'm going to move this diagram over here, um, and this chair. That, yeah, okay. So the force acting on the object when it's up will be the normal force, keeping it at its seat, plus minus the weight of the object because the weight is acting downwards, and that will be equal to the mass times acceleration of the object according to Newton's law. Now in this case, since the centripetal acceleration is always going to be directed downwards, when the object is up, it will be a negative centripetal acceleration. So we'll have something like this: m equals to m, n minus mg equals to mac, negative mac, because it's directed downwards. Now, notice that the mass times the centripetal acceleration is the centripetal force. So overall, the force felt by the object will be the centripetal force. And so let's calculate the normal force, the force that is keeping the object from falling through. So that will be equal to the weight of the object mg minus the centripetal force. And if you notice here, the normal force is smaller than the weight, because the weight is mg, the let's say this is a positive number, subtracting another positive number from it will make it smaller. And so at the top of the Ferris wheel, the person is going to feel lighter than at the bottom. So yeah, let's talk about when the person is at the bottom of the Ferris wheel. I'll just remove this. Okay, so when person is at the bottom of the Ferris wheel, the centripetal force, centripetal acceleration, they are going to be pointing towards the center of the circle, and this time, according to the axis that we set up, is going to be pointing upwards, right? So we can still have that same summation that the normal force is positive normal force minus the weight of the object is equal to the mass of the object times its acceleration. Now, according to the axis that we set up, the acceleration, centripetal acceleration is pointing upwards at this point. So to calculate the normal force will be, um, sorry, this is G. The normal force is going to be mg. This is the centripetal acceleration. This time is positive plus m is. So the normal force, the surface, the chair is exerting on the object is going to be higher, and so that's going to make the person feel heavier at the bottom of the Ferris wheel. And so that's it for centripetal acceleration. Centrifugal acceleration, remember, is the force that the object feels that is that tends to make the object feel like they are going off the circular path. Since the object is moving, or since things tend to move in a straight line, and then the centripetal acceleration is taking them to the center of the circle, they will feel like they are flying out of the circular motion path. So that's all for today's video, and I hope to see you in the next one. Thank you.